Hello, and welcome everyone to today's office hours session for Amazon Aurora. Thank you all for the great questions you've submitted. We've read them all and we'll address them in 5 main categories. Number 1, what is Aurora? Why'd you build it and what makes it different from, or similar to other databases? Migrating to Aurora, how do you migrate databases into Aurora and what do typical migrations look like? Aurora Serverless, which was recently made generally available, we'll dig into some of the details and how you can use it. Compatibility, what's Aurora compatible with? And how do you get started with Aurora and talk with these guys about, what the next steps might be. So sound good? Okay, great. Let's dig into the questions now. So the questions you got in here, let's start with the first one. Why did you build Amazon Aurora?
So I've been in my name's Mark, and I've been in the database industry since the 80s. And relational databases are awesome. They provide, with ACID guarantees, they provide an application programming model, which is amazing. However, the way we built databases back in the 80s and 90s is not how we would build databases today. And around 2006, 2007, as Amazon itself was scaling up, we realized that the databases we were using, while awesome at the things they'd been used for before, were not appropriate for the scale, availability, or durability that was needed to run Amazon.com, nor were they appropriate for those same things for our customers. So what we did was, realizing that, we went back to core principles, and we realized that the main thing that we wanted to do with Aurora is to make it run like a utility. It needed to heal itself. It needed to scale itself. It needed to basically be like that plug on the wall. And we realized we could do this. Now, it took us a while. We started the project a number of years ago, and it took us a while. But as we then worked on it more and more, we found out that we could offer even more features past the basic durability, availability, and performance features. And those are all coming through it being cloud native. And we're going to talk a lot about some of those features today, some of the follow-on features. But basically, some of the things that we're leveraging are, number 1, a self-healing storage system, which we'll get into detail on. Number 2, taking advantage of all of the AWS infrastructure around services and latency and repair and monitoring. And number 3, the concept of having each service do the job it should do. So for example, Amazon Aurora is a great database engine. It is managed by RDS, which is a great database management system, which lives on top of EC2, which has the job of providing efficient and reliable hardware at all times. So all of these reasons are why we built Amazon Aurora. And fundamentally, we are flattered and very pleased that the customer adoption has been so fast because it means that we're delighting customers. And that's always where we're focused here at Amazon, is delighting customers all the time. Thank you.
Well, you mentioned some things around like self-scaling, self-healing. Are these some of the things that are different than other databases? And maybe what else around Aurora is different from what's out there in the market?
Yeah, that's a great question. So the storage system underneath Amazon Aurora is its own component. And its job in life is to let the database always just keep doing transactions, no matter what. And so it's distributed across 3 AZs. And in fact, Srish, maybe you'd like to talk a little bit about some of the details of how that works.
Absolutely. So if I can show you a picture of Aurora's architecture, what you can see on this blackboard is it's one database, right? So when you provision an Aurora database, you have a number of compute nodes, which are your master, where you can issue writes or reads, and then you have a number of read replicas that sit alongside it. But what Mark was talking about was the storage layer that sits in its own multi-tenant system. And so that's the stuff that you see here, the storage layer. It sits across the network. And there are a few things that make the storage layer different with Aurora. First is that the data is striped. So if you have a large, let's call it a 1 terabyte database volume, we break it up into 10 gigabyte chunks, right? The next thing is we take each of these 10 gigabyte chunks and copy it 6 ways across 3 AZs. So think of an AZ as a data center. The third thing is it's actually a log structured storage system. So we don't actually ship data pages from the compute to the storage, we're shipping logs. And the reason all of this matters is that when you start striping your data and copying it 6 ways, you get a lot of fault tolerance that you don't normally get otherwise, right? So we can survive the failure of an entire AZ and 1 more copy. So you can lose 3 out of your 6 copies. And we have a quorum mechanism where we can reconstruct the database. So it's much more fault tolerant than you would find otherwise. The number of copies also makes us be able to reduce jitter. We always go to the fastest copy so that you're not sort of held hostage to the slowest network connection that you have. So better availability, better jitter. But there's more. Because we use a log structured file system, we have 8x fewer IOs than you would in standard MySQL or standard Postgres. So your system runs a whole lot faster. And the other thing is that it's its own layer, right? These are compute and storage servers. They're regular computers, machines. And so you can do things with them which are outside the fast path of your compute engines. We continuously back up data to S3, for example, right? So you don't have to think about backups. It's happening all the time in the background. And some of the new exciting stuff that we're working on, we're actually taking advantage of the compute capacity you have here to run your queries, not just on one instance, but across thousands of nodes in 3 AZs. So those are some of the ways in which our storage layer is different.
A question came in, actually, maybe we can clarify. You mentioned read replicas, and the question came in, why are read replicas better on Aurora? Can you share some of that?
Yeah, absolutely. So again, let's look at this picture here. I talked a little bit about the storage layer, which is on the bottom half of this. On the top half, we have one Aurora cluster, right? So an Aurora database cluster can have one master instance. A master is where you can issue reads and writes, and then you can have up to 15 read replicas. So that's the stuff you see in pink here. So the difference between a read replica, let's say with MySQL, and Mark, you should chime in on Postgres, versus Aurora is that if you wanted a read replica in MySQL, you'd use something like binlog, right? You capture the statements that are coming on the master, you forward them onto the reader, and you replay them there. A couple of things are problematic with this. You're essentially putting the whole write workload also on your reader, even though it's just meant to be a read replica, right? So the amount of capacity you have left for reads is lower. The second thing is that if you have a ton of throughput on your master, your binlog stream may not be able to keep up, so your lag can be higher. So we have actually had customers come and tell us with binlog they're seeing 12 minutes lag, which frankly for an online transactional application is ridiculous, right? So the advantage of having a shared storage layer and a log structured file system is there's not really much traffic between the masters and the readers. They're all sitting on top of the same underlying storage. So if the master can write to the storage, it's automatically available to all the readers. There's a little bit of traffic. I won't go into the details right now. But rather than 12 minutes, we see a typical latency of 20 to 30 milliseconds. That's huge.
And I'd like to highlight milliseconds.
Yeah.
Not seconds even, milliseconds.
Yes, exactly.
Yeah.
And the other part is, let's say your master goes down for whatever reason. It could be hardware failure or something. They all sit on top of the same storage. So you can take any one of these readers and automatically promote them to become the new master. This is not something you even have to do. It's just you pre-configure it, it happens. And it takes between 5 and 30 seconds. That's fast, right? So those are some of the reasons I'd say our read replicas are different.
Gotcha, for Aurora failover. So another question came in, does Aurora support cross-region replicas?
It does. So this, as I mentioned, is just one database cluster, and it's all set up in one region, right? So it's split across multiple AZs, but it's still in one region. If you want to have a cross-region read replica, you could still use binlog, and we give you a managed way to do it on our console or through our API, where you can say, hey, I have my primary database in Northern Virginia. I want, let's say, a read copy in Dublin or in Oregon or anywhere else. You can just set up your cross-region read replica. And many of our customers do this for disaster recovery reasons.
Nice. All right, another question here. Let's talk about performance and scale. Question is, talking about Aurora performance. What is Aurora better than MySQL or Postgres at? What is it the same at?
So I'll take that a little bit. In general, as we started the Aurora project, we talked about the ways of durability and availability, which is some of the stuff we've been talking about. Performance, of course, is a different dimension. And one of the things we did is as we dug into the MySQL and Postgres code bases, and we'll get into compatibility a little bit later in the talk, is we realized that there were opportunities for improvement. And so as we dug into MySQL and as we dug into Postgres, we found contention points inside the database. So for high concurrency OLTP workloads, both MySQL and Postgres both Aurora MySQL and Aurora Postgres perform significantly better than their open source counterparts. Typically, MySQL on some benchmarks performs 3 to 5 times faster, sometimes more. Postgres typically behaves about 3 times faster, 2 to 3 times faster on highly concurrent OLTP workloads. Not only that, the other thing, as if I was sitting there writing an application, I just want to highlight the thing that Suresh said a little earlier, which is jitter is what most applications don't deal well with. If one transaction takes a millisecond all the time, but then 1 out of a million times it takes 3 seconds, that will your application will fall over. And because of what's going on with the storage system, and because of a lot of the stuff we did inside both the Postgres and MySQL code, we eliminated an awful lot of jitter in response times. So,
the one other thing I'd add is there's high concurrency OLTP transactions, right? Which both MySQL and Postgres benefit from moving to Aurora. With MySQL in particular, it's an older engine than Postgres in some ways, and less advanced in query processing. So we have made a lot of changes under the covers so that even though we're still MySQL compatible, we replaced the core query processing components, for example, hash joins, a few others, which actually drive up single query performance as well. So it's not just highly concurrent performance, it's also single queries that we have managed to improve.
Great.
right.
All right, let's get another question here. All right, how would I choose to use Aurora MySQL or Postgres versus regular RDS or MySQL or regular Postgres? I mean, how do you choose this? How do you pick it? What's the decision?
So customers ask us this question all the time, right? And we obviously offer both, RDS MySQL, RDS Postgres, but also Aurora MySQL and Aurora Postgres. The way we look at it, for any workload which you require very high performance, very high availability, or you have a high bar even on things like manageability, right? You want to be able to clone a multi-terabyte database in minutes rather than take a much longer time. Aurora offers a better solution. Now, but we do have customers who sometimes want a very specific version of MySQL. For example, MySQL 5.7.19. Now, Aurora is MySQL compatible, which means that any applications that you write for MySQL, you don't have to change. Off of Postgres, you don't have to change. But sometimes a customer wants a specific bug fix. We do our best to backport all the changes that customers ask, but sometimes we're a little behind. And in those cases, customers will say, hey, I'm used to this. I want this exact version, and I'll go with it. Another example could be that they may want to be in a region where Aurora is not currently supported. Sao Paulo is an example. So in those cases, RDS also becomes a good answer.
Right. So on the Postgres side, because the Postgres open source community is very aggressive with fixes and currently maintains all the way from 9.3 all the way through 10 and now 11 and does bug fixes, we work very hard to keep up with those. So we'll release minor versions all the time. So that isn't as much as a big deal on Postgres. But Postgres offers another dimension, which is extensions. Postgres is a highly extensible database. And in both RDS Postgres and Aurora Postgres, we choose to offer extensions which are safe for us to offer in a managed system. So sometimes we'll see people who need a particular extension, and until we can onboard that to RDS Postgres or Aurora Postgres, sometimes it makes sense to run Postgres on EC2 even. Or another reason you might want to run Postgres rather than Aurora Postgres, RDS Postgres rather than Aurora Postgres, is if it is just a small workload, the latency concerns aren't that big for you. The region dimension is interesting, though there are now, I believe, only 2 or 3 regions we don't offer Aurora. So I just don't want people to walk away thinking that's it. In fact, I believe it's just Beijing and Sao Paulo right now.
That's right.
All other 18 commercial regions offer both Auroras, so that's important. So there's another question that sometimes comes up, which I'm sure is on your list somewhere, which is how do people choose Aurora, either MySQL or Postgres versus Oracle or SQL Server?
Yeah, definitely.
A lot of people have chosen to move away from proprietary databases and are excited about open source. And so when they're moving, what we're seeing our customers choose is really, if they're on a MySQL app, well, they should move to Aurora MySQL. If they're on a Postgres app, they should move to Postgres. That's just easy. But Oracle apps typically move easier to Postgres. Okay. SQL Server apps, we've seen a large portion of our customer base moving SQL Server apps to MySQL. And that's pretty interesting just from a compatibility point of view. Postgres has a more compatible version of PL SQL than for Oracle compatibility. And so people move there a lot. So those are kind of the reasons people choose it. And what they're trying to do really is they're trying to get away from proprietary licensing. And they're trying to get away from core-based licensing. So if someone wants to spin up 100 machines to do a POC on SQL Server or Oracle, they have to go talk to their Oracle or Microsoft rep. in Amazon, you can just spin them up, say that your thing failed and you didn't want to do that POC, and just shut them down the next day. And so you have a lot more control over your cost. You have a lot more control over what's going on. And that's one of the reasons why people move from Oracle and SQL Server to either of the Auroras.
Great. That's actually a great segue into the next question I have here.
Okay.
Is how does Aurora charge?
Well, there's three main components. So again, going back to this picture, when you provision Aurora, what you're effectively getting is one or more of these instances on the top, right? That's what you provision when you go to a console or when you go to our command line interface. And so you pay for the instances, you pay on a per hour basis. And there are some changes with serverless. When we get to it, we can talk about that as well. You also pay for the storage. Now, even though we copy the data 6 ways, you only pay for one of those copies. And then there's IOs that's happening between the compute layer and the storage layer, and you pay for IOs. So those are the three main components of our charges.
So thinking about this, the people trying to build apps on Aurora, how would you be able to figure out how much Aurora is going to cost for them?
The way we counsel our customers on this is start with a smaller instance and measure your CPU and memory utilization. If you feel you need to size up. But a big part of the POC or proof of concept is to make sure that you're sizing your Aurora instances correctly. I don't know that there's a magic wand for this, but this is where we can also help our customers in terms of do the investigation, make sure that you have the right workloads, something that has enough work headroom over what you expect in production.
Right. And one of the things we see on both engines is if you're moving an application from some other database, be it MySQL, Postgres, or Oracle or SQL Server, any of them, you are adapting a new platform. And you need to put in your schedule the concept of tuning for that platform. Some of the queries are going to be faster. In particular, for MySQL and Postgres, they're simpler database engines in some way than the 30 to 40-year-old SQL Server and Oracle. So some queries are just faster out of the box. Some queries aren't. Some queries can actually be significantly faster if you just tune them a bit. And so I think the short answer to, how would I figure out how much Aurora will cost and how do I get my apps over is play with it. Is spin up a small instance and play with it. And the other thing that'll do is just like all the knowledge that you have right now with your other apps on your other databases, you're going to start becoming an Aurora expert. And that's really important as well. So
Great.
just learn that knowledge. Absolutely.
So turn a little bit here. A couple of the questions we're getting right now coming in are around migrations and migrating to Aurora. So let's start with the basic one. I have a database somewhere else. How do I migrate it into Aurora? Where would I get started with that?
So as we rolled out Aurora in 2015, and even before that when we did previews, this question of migrations came up all the time. And so what we did is we started a project that ended up being a service that's now available called the Database Migration Service. And what the Database Migration Service does is it allows you to connect the service to your old database, and then connect the service to your new database, and it'll actually in real time take a snapshot of the data and move all the data over. And it'll keep up, and at some point when all the data is moved over, you can actually just turn off your application accessing the old database and go to the new database. Now that's really powerful for what we call homogeneous migrations. So if you were to, for example, want to move from MySQL to RDS MySQL or move from MySQL to Aurora MySQL, that just works perfect because the data makes sense. However, many of our customers want to move from one platform like Oracle, for example, to MySQL or to Postgres. And so we added the capability to do heterogeneous migrations, i.e. changing in platform. And we built a tool called the Schema Conversion Tool. And what it does is you can run it yourself. It's a laptop downloadable tool. You can just run it yourself. And you hook it up to your database and you say, well, I'm running this SQL Server database and I want to convert it to Aurora MySQL. And it actually gives you an assessment report of everything that will go well and everything that won't go well. So for example, your T-SQL procedures may have issues, or maybe you've used some data types which aren't represented exactly the same way in the new engine. And it gives you this report and a remediation report. And so there's the technical question, which is what I just answered, but there's actually the human and organizational question. There's the old joke about, how do you eat an elephant? And the answer to the joke is that you just pick a place and get started, okay? Because there's no actual strategy for that. And so what we see customers doing is we walk in with our solution architects and we say, why don't we just sit for a day and we're just going to connect to your databases. And we haven't yet seen a customer where by the end of the day, they haven't chosen 4 or 5 databases which look like great databases to convert. And typically they're not the ones that they thought we were going to pick at the beginning of the day. So you want to pick a database of medium complexity. Mm-hmm. You want to pick one that is business important so you can get resources from your managers. You want to pick one that is complex enough that you believe that it matters. But you don't want to pick that mission critical database which, you don't have Aurora skills yet or you don't have MySQL skills yet. You want to pick one that's in the middle. And then what we find is we find our customers actually educate us on how the migrations are going as they pick their databases and they slowly move them over. Mm-hmm. Now, the next thing we found is that actual moving of the schema, the constraints, the triggers, the tables, the indices, all those things, which a schema conversion tool does, combined with the database migration service, moving over the actual data and getting up to date, is typically only about 30 to 40% of the work needed in most application migrations. Now, I'd love to tell you that it's magic and that it just works, but that's actually probably only 10% of the applications just move over and work. Most of them require some degree of work. And so realizing this, we actually have been beefing up here at Amazon our ability to work with customers and the solution integrator partners we're working with to actually help customers do that migration if they don't want to do it on their own. And this involves things like modifying PL SQL, modifying C code, modifying operational procedures, which many of you who are attending today, I noticed from the list, are database administrators. And we love to talk about the database technology up there, but each of you has built around that database technology an operational infrastructure. And we now have the ability to help you. We have a couple hundred people here who can help you and actually talk with you and help you migrate your databases. And it's really not about migrating your databases. It's about migrating your applications.
Awesome. Yeah. And just to let you know, too, for everyone watching, that we do have links in the back of this presentation that you can click on and get more information right away around DMS, SCT, and all that kind of good stuff. Real quick, though, any customer use cases around this that you guys have been around that you want to share?
Yeah. When I take a giant step back and see what do customers use us for, it really spans the spectrum, right? So if I look to the earlier days, our early adopters were folks who were already MySQL users or Postgres users. And you look at the traditional MySQL strongholds, right? So at least for MySQL, it would be things like gaming, internet websites. But especially as awareness of Aurora has grown, adoption and experience with Aurora has grown, we're seeing a larger variety of use cases come to us. And so we're seeing a lot of SQL Server and Oracle migrations, as Mark just mentioned. And for example, one of my large customers, they run a mission-critical e-commerce workload on Aurora MySQL. We have others that have, for example, moved from Cassandra to Aurora. And you would ask, why would they do it? These are companies that at some point decided, hey, they wanted a relational model because that was actually a better use case fit for what they're trying to do. And so we've seen migrations coming from places which we didn't frankly expect or design for, but people are finding uses for Aurora.
So we've also seen on the Postgres side, we're seeing an interesting vertical assimilation. Most of the ride-sharing companies that you guys use every day are running on one of the 2 Auroras as their backends, and that's really interesting. And as we dug into it a little bit, we determined that what they had done is build this microservices-based architecture. These are all pretty new companies. And what those microservices needed was they needed some layer of consistency across, which of course, a big database can do that. But they actually had 10 to 20 microservices just doing almost these micro OLTP transactions. And what they didn't want was they didn't want one database microservice being affected by another one. And so they split up their workload into fleets and all this. And so as we've seen them onboard, it's actually been easier for them than they've thought. The other use case which we're seeing is very interesting is financials. So, I go back a long ways in the database industry, and no matter what we tell people or told people then about failovers of on-premises situations, here's the way it really goes. You have a database failure, and it's down for 3 hours, and then 3 days later you tell your CTO or your CEO why it was down for 3 hours, and you promise it'll never happen again. And then 3 months later, you have another failure, and you promise that it will never happen again. And as I say this to customers, they're like, yeah, that's exactly what happens at our company. Well, the RDS fleet with Aurora in it is one of the biggest fleets in the world. And we launched in 2009, 9 years ago. We have crawled into what we like to call all the deep, dark corners of high availability. And so when people migrate to us, one of the things they don't have trouble with is the system staying up. And we're really proud of that, actually, and it's something that we work on every day. And one thing is that any failover that takes longer than our advised times of 5 to 30 seconds or 60 seconds on RDS Postgres, every single one of those is looked into by our operations team. And that's an awful lot. And so, as people migrate, one of the things we're trying to do again is make things feel like a utility. You never know when they put another turbine on at the dam, 100 miles away. You never know when a transmission line fails. And we'd like to make Aurora and the endpoint for our 2 Aurora databases feel that same way. So we have a storage system which does that. The storage system just keeps running. But then in the engine, and we're going to get to this a little bit more in the next section, the engine itself is meant to just keep running no matter what.
Yep.
And for you never to have any reason to shut down your database. So.
Great. One question that came in, I do want to bring up, maybe talk a little bit more about, someone had a question on performance insights and where that fits into this. Anyone know?
Yeah. Do you mind if I take that?
Yeah, go for it.
So when I was back at Oracle, we had various features we built into the Oracle kernel, and those were around knowing what was going on with every session in the database. And then over the next 15 years, we saw MySQL add that, we saw Postgres add that. But what you had to do with every single one of those is you had to actually go and add a product and install a product and create hard drive space. And you had to do all this, and then you had to stand up consoles. And so what Performance Insights is all the performance data that you want on your databases monitored down to a per second data basis. And you just do one click on the console and turn it on, and all of a sudden you get your data. And so it'll show you the wait states in your database. It'll show you the slowest SQL statements. It'll show you whether disk I/O is taking too long. It'll show you whether transaction locks are taking too long. You can Google on YouTube Performance Insights, and you can all obviously reach out to any of us for that. But it also does something else, and this is for people who are actually writing applications. It does something which we knew was going to happen, and we're very happy. Most of the time when a DBA gets involved is when the utilization on the database has gone from 90% to 101% and the database is down or the database is lagging. What Performance Insights allows you to do is notice that on last Tuesday at 12 p.m., your database got 10% slower. Now, it only went from 30% utilization to 40% utilization, and in the old world, that's all good. Everyone's fine. But most times when you see a database get to 100% utilization, it's actually 5 or 6 deployments over the last number of months, and it's too late to roll those back.
Yep.
And so by doing this, we can help application writers actually look at their status, see what the database performance was before the deployment, see what it was after the deployment, and fix it right then. And so Performance Insights, as part of the product, allows you to store 2 weeks of data. Okay, right there. And then you can opt in to it storing 2 years of data as well. Because maybe you have an application where you're doing your quarterly close, and you want to look at how the application performed in last quarter's close as opposed to this one. So for those of you who use RDS, I'd strongly advise you to go and check Performance Insights on the console, turn it on. It's now available for Aurora MySQL, Aurora Postgres, MySQL, and Postgres. Yep. And Aurora, Oracle and SQL Server are coming soon.
Great. No, thanks. Great. So the next section, there's a bunch of questions on recently generally available serverless, Aurora serverless. Maybe we can start with what is Aurora serverless and why did we build it?
So, Aurora serverless, it addresses one of the questions that we just talked about. How do you figure out the right instance size for your workload, right? Aurora serverless essentially takes this problem away because we figure it out for you based on your application load. So if you go back to this picture here, right? So let's just focus on one instance. When you provision Aurora, today you go to the console, you have to figure out what your size is. Is it an R4 large? Is it an R4 16 large? And based on your workload, you may have times when it goes up, it goes down. A lot of our customers, I mentioned gaming as an example, they have workloads that are fairly, 10x different depending on the time of the day. Or you may have a dev test workload, which you spin up, do a lot of work, and then you just forget about it because you forget about it. You're done with your dev or test. In these instances, let's say that you provisioned an R4 16 large, 16x large. That instance is still there, and you're being charged for it, even if you're not using it to the capacity that you provisioned it for. So what Aurora Serverless does for you is that when you provision Aurora, you get something called a serverless endpoint. That points to an instance under the covers, which is transparent to you, and it sizes up or sizes down based on your observed CPU and memory usage. Now, there are a few use cases where this is very powerful. I mentioned dev test. So you don't really have to worry about tracking, all your developers, how are they using Aurora, where is the spend going. You can spin all the way down to 0. And if you come back up, you can spin up an instance again. So that's huge. Another one is your production workloads, where you go up and you go down. And again, we take care of it for you. So if you have spikes.
A little thing for the people on the call. Can you clarify a little bit what you mean by spin down to 0? Because that might not be as clear anymore.
So one of the things I didn't mention here is that these compute instances, they all sit on top of the same storage layer.
Okay.
Now the storage layer is long-lived, right? So let's say you have a 1 terabyte database, it stays. If you don't need any compute instances at all because you're not running any queries, you could just take away this entire layer on top.
So it actually won't spin down to just the smallest instance.
No,
it'll actually
it goes away.
And then how does it get configured again when it comes back up?
When it goes all the way down to 0, you still have your storage layer underneath.
Mm-hmm.
And so when it comes back up, we just add another machine and it connects to the same storage layer.
Cool.
And we use a warm pool of instances, so it's fast. So when you go up or go down in size or go all the way down to 0, it takes less than 5 seconds. And we also make sure to transfer your buffer pool contents, because that's actually one of the big deals, right? So if you scaled up today without serverless, you're getting essentially a new machine with a cold buffer pool. And that means that until the buffer pool warms up, your performance is not quite where it needs to be. And the third thing is because you don't see the instance directly, you just have the serverless endpoint, your application doesn't see any sort of disconnection. All of that happens under the covers. So you don't see any disconnection, it's fast, and you get a warm buffer pool. That's serverless.
So you mentioned like dev test and gaming and stuff, and I see this also for developers, right? Like, hey,
Absolutely.
I don't know if my app's going to take off. Are there any other use cases you would see this used for? Because this sounds really exciting for that.
Yeah, we just got started earlier this month. We launched in the beginning of August. Dev test production workloads which are very spiky, those are the ones we're seeing. Mm-hmm. But like I said, we always get surprised by our customers because they find uses of Aurora, which honestly, we're happy when we see our customers use our databases in ways that we don't imagine.
So
pretty cool.
Available today on Aurora MySQL, correct?
Mm-hmm.
How about serverless on Aurora Postgres?
So we don't actually give dates on stuff we're working on, but we are working on serverless on Aurora Postgres, and we're pretty excited. Some of those same use cases that people are seeing, and so we're working on it right now. So, and if you guys have use cases for serverless on Aurora Postgres, my email's at the end of this presentation, and let's chat.
Great. Another question: how can I migrate from standard Aurora to serverless Aurora?
You take your standard Aurora database, you just snapshot it, and you restore it into Aurora. Reach out to me if you have any questions. The docs are online, and there's videos as well.
Okay.
Great.
Interesting. Okay.
So
Are there any gotchas where you wouldn't want to use serverless?
So if you have a workload where you have very predictable load, and you provisioned, you don't really see the ups and downs. Mm-hmm. The pricing model is slightly different for Aurora. So on a per hour basis, it costs a little bit more. So if you have a very steady load, there really is not a reason to use serverless. But otherwise, based on the other use cases I mentioned, serverless would be a good fit.
That's interesting. Cool.
Cool. Let's skip the next area here. Let's move into compatibility. Mm-hmm. Aurora compatibility. So let's talk through how compatible is Aurora MySQL with MySQL?
So it's wired protocol compatible, which means that if you have an application running on MySQL 5.6 or 5.7, you have to make no changes to use Aurora.
So for Postgres, I'll tease that apart a little bit if that's okay. So for customers, I often find that they're being challenged by their management who might have been in the situation of using a proprietary database for many, many years. And the last thing they want to do is move to another proprietary database and have lock-in. Sure. And lock-in's a real concern. And we address this every day. And one of our goals is to never have anyone feel scared of lock-in. Mm-hmm. And so there's a lot of choices we make in the product and in compatibility, just like Suresh said. And so, but compatibility is an interesting, nuanced area. So if you think about application compatibility, at least with Aurora Postgres, if it's not application compatible, we'll treat it as a bug and we'll go fix it. no doubt about it. And that's for any version we offer.
Yep.
Okay. Then there's management compatibility. Well, it's the same database, it obeys the same commands, but there's a couple things which would be different. Like you wouldn't ask how much space was left on your file system because there's no such thing as space left on your file system. So it's a little different there. But management compatibility is pretty close. And then finally, there's the way you think about compatibility from, merging and compatibility and patching and all of those things. And both engines stay very, very current with the patches that come from the community and merge with them regularly. So you don't have to be worried that some security exploit is going to come out on either MySQL or Postgres, and it's going to have this huge lag before you can use it in your system. And so as I talk with customers, those are the various ways that people think about it. Now, it's also true that customers will still bring up lock-in. And we just like to go back to if it's not wire protocol or application level compatible, it's a bug.
Yep.
And we will address it as a bug. And so, it's important that people feel comfortable with that. So, one of the jokes I like to make is that the only reason I would like you to move off Aurora Postgres or Aurora MySQL is because you want lower availability, less durability, lower performance, and you want to pay more. I don't ever want you not using or moving off of our products because you're concerned about lock-in. So
The word that comes to mind is freedom. Right?
Yes.
People want freedom, and we want to give them freedom.
Well, I'll give them freedom. Yeah.
Great.
At Inside, we like to have a phrase which is, we earn your business by the hour, every hour. That's it.
That's good. Maybe a question here, people, how to get started with Aurora? How do they?
So if you're spinning up a new workload, you just go to a console, you can spin up an Aurora cluster, you get something called a cluster endpoint, which is how your application can connect to your database. It looks just like MySQL or Postgres, and you can start working with it. If you have an existing workload, Mark mentioned a number of migration options that are available. We have managed options if you're already on MySQL or Postgres, but if you're coming from a proprietary database, tools like DMS and schema conversion tool can also help. Anything you'd add, Mark?
Right. Well, I think that one thing I'd say is that a lot of our customers are doing new application writes, and that's really fun. And, like Suresh said, you can just get those started and move over things. A lot of customers are actually doing application refactoring. And in fact, some of them are doing whole business refactoring as they move out of their data centers into the cloud, or they move off of EC2 onto managed databases. And so, one thing I'd really advise is, have an SA, a solutions architect, come visit you and chat with you and really help. Now, you can certainly stumble through the forest of all the different AWS services and documentation, and there's so much of it out there. Or you can have someone guide you through the forest really quickly and really efficiently. And we're really proud of our SAs and the service team. We work with those teams all the time and do training sessions with them and keep them up to date.
Yep.
And in particular, whenever they have a problem with customers, they bring it back to us in the service teams all the time. So as you get going, imagine that there's this continuum of ways to get started with Aurora, which are, hey, I'm just going to do it myself tonight, to all the way to bringing Amazon in to help you. And we want you to find your comfortable space anywhere on that spectrum.
Great.
Okay.
Great. So let me look here. Got a couple of questions. What I'd like to do is go to a couple live questions if possible.
Okay,
And,
sounds great.
Let's. One of these here is, how good is Aurora for batch processing? When would I use that?
Interpreting the question as, I have large queries that I want to run periodically. We do have several customers take advantage of the fact that we have up to 15 read replicas on a single database cluster. So what they'll often do is they will take the master and perhaps a couple of replicas and say, this is what I'm going to use for my online transaction workload. And they may have a few other replicas that they use for long-running queries, as an example. So this is already something customers do. They do it well. But with features like parallel query that are coming up, you can also push down some of these larger queries down to the storage layer and experience 1 to 2 orders of magnitude speed up. Now, remember that Aurora currently has a 64 terabyte size limit in terms of the volume. It's a soft limit, but it's a limit. So if you're talking about data sites that exceed that, or you have very complex reporting, you can still offload the data from Aurora into a data lake or data warehouse and use tools like Spectrum, Redshift, or Athena.
Right. The other thing we see people do is we have a feature that we've launched called database cloning. And what database cloning allows you to do is take at a point in time, say, I'd like to have another set of instances all connect to that same database. And it takes on the order of a minute for it to come up. And what we're actually seeing customers do is they'll clone their database, which takes their entire database at one point in time. And it's not a copy. It doesn't take a very long time, as Serge said earlier. And then they'll run their Netlib reporting on that database. And then they'll just shut it down when they're done. And so we see people doing that all the time. You could do it either way. It doesn't really matter. And we see people playing with both options. So yeah, we see a lot of people using it for batch processing. And obviously on any OLTP database, the one thing you want to avoid at all costs is interfering with the transaction processing going on the master with a big read-write query that might slow it down. That being said, we see people who do that in their current MySQL, Postgres, and Oracle environments, and they just move those applications over and they work just as well. But what I would rather have people do is scale down that master so that they're paying less money most of the time, rather than have it scaled for peak performance all the time. Scale down the master to really be that, and then stand up either replicas or clones as appropriate for their batch workload. So one of the things you want to do in computer science these days is decouple, decouple, decouple. And what happens on most systems, in particular core-based licensing systems, is you stack everything up on one CPU and then you all get in there and you share it together. That's something that people do as a necessity, but it's not something you should do in the new world. You should decouple everything you can do. You should let one team do your batch processing, one do your OLTP, and the only thing they should share is that storage system.
Great. I'll take one last question here. We have time for. We talked about serverless, a lot of great things about it. When should I not use serverless?
So as was just mentioned to Mark on that, there may be situations where you have a very steady, predictable workload. In that case, the benefits of scaling up and scaling down are not really applicable to your workload. And so serverless may not be the right fit.
Right.
Gotcha.
There are some temporary limitations that you should be aware of, which we're working on removing. Right now, serverless only supports a single instance on a database cluster. You can do both reads and writes. But if you have an existing workload that already heavily relies on read replicas, we're not yet ready for you, but we hopefully will be soon.
Yeah, great. There's a lot of questions actually coming in that are very specific to different types of situations, whether it be, hey, how do I move from SQL Server onto Aurora and Oracle, et cetera? And there's a lot of great information. And I'd like to say, like, on the website, we have that, or reach out to us. Because, there's a lot of great detail here, and there's a lot of people have done this already, and there's a lot of great experience that can help you on this journey. On that, I want to thank everyone for the time here today, and also direct you to the slide that's up there right now, which will then give you the quickest and best links to all the details that we have up there, our personal information if you want to reach out to us about any questions we had here today. And as Mark said, we're going to be reaching out to you. Basically, the answers that we couldn't connect with and we couldn't answer here today because you sent a lot in, we'll reach out to you directly to see what we can do. But thank you again for all the questions and for your time, and we look forward to speaking with you soon.
And thank you for placing your trust in Amazon and your trust in Aurora.
Thank you.
Thanks.